So I just want to make sure one more time what type of material this is. And so I'm going to go back to our sorting effort. So I'm going to set this up at 50 kilohertz. Okay, there's 50. Phase angle we're going to set at 153. Oops. Okay, I set the phase angle at 153. I'm going to set the gain at 53, vertical, horizontal and vertical. So now I'm going to set the horizontal gain at 53. Okay, and the vertical gain at 53. Oops. Okay. Okay, so the vertical gain is at 53. Now remember, I'm trying to sort this material, so when I do my nulling, I want to be in the middle of the air somewhere away from any conductive material. So now I hit the null button, and it should show me a 0 in the oscilloscope screen. So now I'm going to take this data, okay, so the figure of the electric current goes off down to the right, okay. So if I go back to my calibration block, so the question I had is what kind of steel is this? And I thought at one time it was stainless steel. So we have our calibration standard, there's stainless steel. So it doesn't look like stainless steel because that's coming off this way. If I look at my ferrite steel, it looks almost like ferrite steel. Okay, so it's probably carbon steel with some ferrite content. Okay. Alright, so I'll only just show one more thing, and that is when we did our defect figures on the different sizes of depths. Remember, for aluminum we got something that looked a lot like that, so we can figure this is less deep, a little bit deeper, and this is the most deep. So this is going to be the phase angle. We're going to calculate that, and we'll talk about that in our class on Thursday, our next class. Okay, so I think that's it. I hope you learned some information. This is the eddy current probe. This is our calibration standard. It's very important when you're doing eddy current to have a calibration standard, because you've got to have something to compare with. It's a little bit different than ultrasonics, where you can just take any piece of material and based upon measuring its thickness or something else, you can calculate velocities and stuff. So just for fun, let's do this unknown aluminum. And so I would like to know if this is good for aircraft parts. So let me, again, null my instrument in the air. And all I have to do is touch the material. And there I get my signal. So the question is this 775 T6 or 7075 aluminum? Here's 7075 aluminum. And it looks pretty close to that. Here's T6. So it's not quite T6, so it's 7075. So there's a certain material, and that allows me to go sort through the material. So if you get material in your manufacturing facility and you have a known standard based upon something else that somebody gives you, like a reference, then you can start using this technology to do sorting, and you can see it's very quick. So you can certainly see the differences very quickly. Okay, thank you very much. I hope you enjoyed it. We'll be talking more about eddy current.